Today I'll be solving section 4.1 statistics, so let's begin inshallah. An arrangement is randomly chosen from the 7 letters of the word liberty. The probability that R appears at the beginning and the letter B appears at the end is 1 over k. Where k is an integer, what is the value of k? So, they gave us that we have 7 letters in the word liberty. So we do 7 factorial. To find first of all, we need to find the total arrangements. So we do 7 factorial divided by, are there any repeating letters? No. So we just simply do 7 factorial. And so we get the answer of 7 factorial on the calculator. We get 5040. So they want the probability that R appears at the beginning and B appears at the end. There's 5 letters in between. So 1, 2, okay. R is fixed, B is fixed. We cannot change their arrangements since the question itself fixed them in their places. We can only change the arrangements of the 5 letters in between them. So we do 5 factorial. And to get the probability, we do the arrangements that R appears at the beginning and B appears at the end divided by the total arrangements. So we do 5 factorial divided by 7 factorial. We get 1 over 42. And they want the value of k, so we just simply put 42. Inshallah. The probability that byte appears in this order. They fixed byte. Like byte, it's together. We consider it as one block. So we do byte, B-I-T-E, and there's 3 extra spaces to make 7. So we consider this as one block. So it's 1, 2, 3, 4. 4 factorial. And to get the probability, we do 4 factorial, which are the number of arrangements of bytes, and divided by 7 factorial. We put it on the calculator. We get 1 over 210. And they want m, which is simply 210. So we put 42, 210. Question 2. How many different arrangements can be made with the 8 letters of the word capacity? This question has repeating letters. So we have C, there's 2 C's, and there are 2 A's only. So we need to find the total number of arrangements. So we do 8 factorial. And if we have repeating letters, we do the number of times it has been repeated, factorial, times the other letters which have been repeated. So 2 factorial. 2 factorial times 2 factorial, because there are 2 C's and 2 A's. So we put them on the calculator. So we do 8 factorial divided by 2 factorial times 2 factorial. We get 10080. How many different arrangements can be made with the 8 letters of the word capacity that begin with T and end with P? 1, 2, 3, 4, 5, 6. So they fixed T, they fixed P. So we can only arrange the 6 in between. So we do 6 factorial. And T is not repeated, P is not repeated. Only the 2 C's and the 2 A's. So like the first part, we do 2 factorial times 2 factorial. If, for example, T was replaced by C, there would be 1 C left, and we simply just divide by 2 factorial for the A. We forget about the C because there's only 1 C left and it's not repeated. If it was 3C, we divide by 2 factorial, because one of them was fixed. So for this question, it's 6 factorial divided by 2 factorial times 2 factorial. We get 180. Okay. So to 3 decimal places give the probability that an arrangement of the 8 letters of the word capacity picked at random begins with T and ends with P. So, the probability of this word starting with T and ending with P is 180 divided by the number of total arrangements, which is 10080. So we find the answer on the calculator. We do 180 divided by 10080. We get 1/56, which is equal to 0.017 or 1/8 if we round it to 3 decimal places. So this is 10080. This one is 180. And this one is 0.018. Question 3. Chris, Naomi, and Tom and 8 other classmates are randomly divided into 2 groups. One group consists of 6 students and the other consists of 5 students. The probability that Chris, Naomi, and Tom are in the same group can be expressed as this fraction. So we have Chris, Naomi, and Tom and 8 students. If we add them all, 8 plus 3, 8, 9, 10, 11. It's 11 students in total. So we can consider Chris, Naomi, and Tom as a group on their own. So we do 3. We choose 3 from 3. So we do 3 combination 3 times. And we still need 6 other. So we need a group of 6 and a group of 5. So we remove Chris, Naomi, and Tom from the 11. So we do 11 minus 3, which is 8. And we choose 3 more to fill in the group of 6. And then we do another 3 combination 3 to fill in the group of 5. So we do 3 combination 3 times 8 combination 2. And we find the answer of each one by putting them on the calculator. So, inshallah. So 3 combination 3 times 3, 8 combination 3, which is 56. And then we do 3 combination 3 times 8 combination 2, which is 28. Then we add them. So we do 28 plus 56, which is 84. Then we do 84 divided by the total number of arrangements. The total number of arrangements, it's either 11 combination 6 or 11 combination 5. Either way you get the same answer. So you do 11 combination 6, you get 462. We should have calculated this in the beginning, but it doesn't matter. So we do 84 divided by 462 to get the probability. So they didn't simplify it, so you keep 84 as it is. You don't simplify the fraction of the denominator. They gave it to you 462. If they simplified it, you simplify it as well, because they don't want it simplified. So we just simply write 84. The probability that Chris, Naomi, and Tom are not all in one group can be expressed as m over 462. If you think about it, Chris, Naomi, and Tom not in the same group is the opposite or the complement of them all being in the same group. So you do 462, which is the total, minus 84. So we do 462 minus 84, we get 378. So if we take the total and we remove them being in the same group, we get the number where they're not in the same group, which is 378. And then we simply divide it by the total number of arrangements which we found to get the probability of them not being in the same group. So it's 378. So it's 84 and 378. Question 4. A jeweler has a bag that contains 10 stones of different size. 7 of the stones are amethysts and the remaining 3 are sapphires. What is the total number of selections of 4 stones from the bag? They didn't specify which stone that they want. So we simply do 10, like we're choosing 4 from 10. So we put it on the calculator. We're choosing any random 4 stones. So it doesn't matter. So we could use combination. So we get 210 on the calculator. How many selections of the 4 stones from the back contain exactly 3 sapphires? So they want 4 stones and they want 3 sapphires. And they told us that we have 3 sapphires. So we're choosing 3 from 3 sapphires times 7, which are the amethysts, combination 1, because we need to fill in the 4th spot. So we do 3 combination 3 times 7 combination 1 to get the answer. We get 7. Okay. How many selections of 4 stones from the back contain exactly 3 amethysts? So same scenario. So we do 7 combination 3. We're choosing 3 from the 7 amethysts, and to fill in the last one, you multiply it by 3 combination 1. So we do 7 combination 3 times 3 combination 1. We get 105. Okay. It says how many selections of the 4 stones from the bag contain at least 3 of the same type. So it can be 3 or 4 or more. Because they want, like, the maximum is 4 stones, so it's either 3 or 4. And we have only 3 sapphires. We cannot choose 4 sapphires. But we have 7 amethysts, so we can choose 4 amethysts and 0 sapphires. So we can use part B and part C, but then we add to it an extra step. So we do 7, we're choosing 4 from the 7 amethysts times 0 from the sapphires, in which we get 7 combination 4 times 3 combination 0, which is 35. And then now we can add them to parts B and C. So we do plus 105 plus 7. We get 147. We cannot see the last part now, but it's asking about the probability. But I'll show you the question. So wait, this is 210. This is 7. This is 105. And this is 147. What is the probability that a random selection of 4 stones from the bag contains at least 3 stones of the same type? Which is part D, but they want the probability of it. So we do 147 divided by the total number of selections, which we found in part A, which is 210. So we put it on the calculator. We do 147 divided by 210. We get 0.7. It used to be wrong in the quiz, but now they solved the problem. Now this question says a group of 5 students are signing up for an after-school activity. Each of them can choose one activity among X, Y, and Z. The students decided to choose activities randomly. Each student can choose one from 3 options. There's 5 students, so 3C1 times 3C1 times 3C1 times 3C1 times 3C1, which is equal to 3C1 all to the power of 5, which is equal to 243, because they want the possible number of ways in which the students can choose the after-school activities. I got this way from Sabis Education since I didn't understand how to solve it. Now they want what is the possible number of ways in which all 5 students choose either Y or Z. So there's 2 options, they can choose one. And for all of the 5 students, 2C1, 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 which is equal to 2C1 power 5, which is equal to 32. Now it says, what is the possible number of ways in which exactly one student chooses X? So he has one option, he chooses 1, while the other 4 students choose either Y or Z. So we have 1C1, 2 options, C1, 2C1, 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 which is equal to 2C1 to the power of 4. You should get you should get 16. And then, since this human, this student that chooses 1, he can be any of the 5 students. So we can do 5C, this 1 student, which is equal to 5. And then we multiply these two values. We do 16 times 5, which gets 80. What is the possible number of ways in which exactly 2 students choose X while the other 3 students choose either Y or Z? So we have 1C1, 1C1, 2C1, 2C1, 2C1. So 2C1 power 3 is equal to 8. And these two people who are choosing 1 can be any of the students. I didn't understand this, but I understood the rule. So since it's 2, we do 5C2, which is equal to 10. Okay, you get 10. Since these are 2 that choose X by itself, and this one chooses X by itself, 1 student, these are 2 students, so we add 2, then we do 10 times 8, we get 80. Now they want what is the probability that at most 2 of the students choose X, which is 0, 1, or 2. We found these in the last 3 parts. This is 2x, this is 1x, this is 0x. So we do 32 plus 80 plus 80, which is 32 plus 80 plus 80, we get 192, divided by the total, which is 243. We should get to 2 decimal places, 0.79.